Today's class M.G.SRT.B.05 Real World Applications of Similarity and Congruency. Purpose of the day. In today's class, you will be learning to solve real world problems about congruence and similarity, congruence or similarity. So it depends upon the situation in the geometric figures. An application of similar triangles is to measure lengths indirectly. As I discussed before, suppose if there is a multi-storied building which is say 30 stories or 40 stories, if you have to find the height of the building, then you need not climb up to the top of the building and you need not drop a measuring tape kind of thing or drop a rope and then measure the length of the rope. Those kind of things you need not do it. That's the best part of the similarity. The length to be measured would be some feature that was not easily accessible to a person, such as the width of a river or width of canyon and the height of a tall object. Even you can find the height of Eiffel Tower using similarity without climbing that. To measure something indirectly, you need to set up a pair of similar triangles. Okay? Now, here I'm giving you a situation. Mr. Bigay has given the honor of hoisting the flag at his school. He stands next to the flagpole while he hooks the flag. His classmates notice two shadows. Mr. Bigay is 4 feet tall. You can see that Mr. Bigay is 4 feet tall here. I request all of you to watch this one on a full screen mode. Mr. Bigay is 4 feet tall and his shadow is 6 feet away from him. So here, his shadow is falling on the ground, which is 6 feet long. The distance of flagpole's shadow is 25 feet. So here the length of the shadow of the flagpole is given as 25 feet. But the students don't have a direct way to measure the height of the flagpole. So they don't know what is the height of the flagpole. You may get a doubt. What is the need to find the height of the flag post? Because this guy has been given the honor of hoisting the flag at his school. Suppose here, if you want to know what is the length of the rope needed, so that he can hoist the flag. So to go to store like Walmart and to buy the rope, he should know what should be the height of the pole so that he can buy the same length of the rope. Does it make sense? Okay. Now, how many right triangles do you see here? Think for a moment. How many right triangles do you see here? Okay. I see that there are two right angle triangles. One is this one and one is this one. Okay. These two triangles are similar. How can you say that these two triangles are similar? Means at a given time, the sun rays are parallel at a place. So these two are parallel lines. If these two are parallel lines, obviously the corresponding angles are equal. So I see that angle equals to angle. Angle equals to angle. And the second one is here 90 degrees. I see that this is perpendicular. And this one is also this person or Mr. Mr. Bigay is standing, therefore to the ground it is 90 degrees. Therefore 90 degrees equals to 90 degrees, so angle equals to angle. So by a similarity, these two triangles are similar. These two triangles are similar. If they are similar, then you have to set up a proper proportionality. Remember, if two triangles are similar, then the sides are proportional. Sides are proportional means, for example, if I'm taking, let's say that the vertical line, if I'm taking the vertical line, okay, then the corresponding side is the height of the person or the vertical line. Okay, so these are the corresponding sides. Now let me clear this one, otherwise it looks ugly. So let me take that. First of all, if no letters are given, or else if it is not labeled, yes, you better label the triangles. A, this one is B, and this one is C. And let me take it as P. Let me change it as Q here and R here. I'm naming and I'm labeling this one as a triangle ABC and triangle PQR. Okay? By proportionality theorem, by proportionality theorem, proportionality theorem, we take sides. I'm taking the vertical line, that is AC, and the vertical line is PR. Please notice that I'm taking the numerator is the large or the big triangle sides, and the denominator I'm taking the small triangle sides. Okay. In the same way, if I'm taking BC, please notice that BC is one of the sides of the large triangle, and the corresponding. You can see that if I'm taking BC, the corresponding side is QR. The corresponding side is QR. So let me take BC over QR. Now just plug in the values. The value of AC, I don't know. So let it be X. The value of PR, I see that 4 feet in the diagram. The value of BC is 25 feet, and the value of QR, that is 6 feet. At this point, how to find the value of X? Do I have to add, subtract, multiply, or divide? Think for a moment. We go for cross multiplication. That gives me that 4 times 25 equals to 6 times X. Please. So here the next step is division by 6 on both the sides. So 4 times 25, that gives me 100, divided by 6, that is 16.6. Of course, if you are rounding it, it is 16.66, or maybe I'm not rounding here, it is 16.6 feet. Suppose if I'm the student and if I have to bite the rope, instead of taking 16.6 feet exactly, I may take a little longer than that, maybe 17, not even 17, I may go for 18 feet length rope. Okay, now it's your turn to establish a proportionality and solve it. First, the hint comes. Don't forget to draw a diagram. Here I'm not giving the diagram. Yvonne is 6 feet tall, casts a 15 feet shadow. At the same time of day, nearly a nearby building casts a 30 feet shadow. How tall is the building? So here I want you to draw a figure that represents the above scenario. I'm giving you a small clue. You need not be an artist to represent this situation. Okay? So this is the building. This is the building. and here is the shadow of the building. And Ivan, he is not as tall as the building, okay, and his shadow is falling on the ground here. Now here you may label both the triangles, and you can take you can label the parts like this is A, this is B, this is C, and maybe this is P, this is Q, this is R. Now input the numbers. Please read the question carefully and identify the important information from the question, and then label the parts, then set up a proportionality to solve. So Ivan is 6 feet tall, therefore 6 goes here, and casts a shadow of 15 feet, so 15 goes here. At the same time, come on, there's a typo error, at the same time. At the same time, a nearby building casts a 30 feet shadow, therefore this is 30 feet. And how tall is the building? So here is the question. So if I'm trying to set up a proportionality, you can take the numerator, either the small triangle side or the large triangle side. For example, if I'm taking PQ, so this is small triangle side, and I see that this is the vertical line, so you have to take the vertical line of the large triangle, which is AB. Okay, so I'm taking the sides of the small triangle and I'm taking the sides of the large triangle in the denominator. So again, small triangle one side, which is the horizontal one, it is QR over the horizontal side of the large triangle, which is BC. Now let's plug in the values. PQ equals to 6 units. AB, I don't know. QR, it is 15. And BC, that is 30 units. Now you go for cross multiplication. It is 6 times 30 equals to 15 times x. You know how to isolate the value of x. So when you do the calculations, you should get x is 12 feet. So the height of the building is 12 feet. During testing, 21 also seems to be, it seems to be similar to 12. So don't be in a hurry, excuse me, while opting the answer. Okay, so let me go to the next one. Let's do some more problems from the worksheet. Let's do. The first point is check whether the given triangles are congruent or similar. And also you have to label the diagram. Make sure that the given triangles are having the same orientation. About the orientation already I discussed in my previous class, but I'll take maybe a couple of questions in today's class. So make sure that the triangles are having the same orientation through reflection or rotation. When two triangles are similar, then the sides are proportional. You have to use this concept. So let me take one question. The first question already we discussed this kind of scenario. So even the second question also we discussed. Let me take the third question. Okay. There is a story, but instead of the story, let me copy the diagram. This is giving us a clear-cut idea what to do. So let me quickly jump to the whiteboard. Okay. I see that a person standing on a tall building. He noticed that a ship is approaching towards the building. And the height of the person is given. The shadow, you can see that the height of the person is given here 5.5 feet, and the shadow of the person is given, height of the building is given, and the question is what is the distance between the boat and the building? That's the question. Okay. Now, first of all, I see that two right triangles here. One is the person and his shadow. This one is making a right triangle, and the second one is the building is standing on the ground. Of course, it is 90 degrees, and the boat is approaching towards the building. So that I see that another right triangle. Suppose if the triangles are not labeled, then you can name them like A, B, C, P, Q, R. What are the letters you want? I'm taking here A, B, C, D, E. I see the two right triangles. Okay, and then how to find means, first of all, you have to set up a proportionality. If I'm taking a vertical line here in the small triangle, and then I have to take the vertical line, as simple as that. Okay, therefore, by proportionality, AB over CD equals to, then I'm taking the horizontal line, which is BC, over I'm taking the horizontal line here, which is DE. Therefore, that is equals to BC over DE. Now plug in the values. AB is 5.5 over vertical line CD is 35 feet equals to BC is 10 feet over, I don't know what is the value of DE. As you know that at this point we have to go for cross multiplication. Then the calculation goes this way: 5.5 times DE equals to 35 times 10. You know how to isolate DE, so we have to go for the division by 5.5. Then the value of DE is, let me grab my calculator, you also can compute it, which is 35 times 10, divided by 5.5. That gives me 63.63, these many feet. So that is the distance between the boat and the building, 63.63 feet. Okay, let me take one more question. In fact, this question is straight away, I'm sure you can compute it. The value of the length of the stick is given, the length of the stick's shadow is given, length of the building shadow is given, and you are asked to find the height of the clock tower. You know that these two are similar triangles. I'm pretty sure that you can set up a proportionality, then you can compute the height of the tower. Okay. You know, there are some story problems. Like whatever the question you take, first of all, you have to draw a picture that represents the given story. Then you get a fair idea what to do. Look at this question. Sally and her little brother are walking to school. Sally is 4 feet tall and has a shadow that is 3 feet long. Her little brother's shadow is 2 feet long, and how tall is her little brother? So, first of all, always identify The key information: Sally is 4 feet tall and has a shadow is 3 feet long. Her little brother's shadow is 2 feet long. So her little brother, let's say that Sally, because she is the eldest one, so that she must be taller to her brother. And here is just I'm drawing a little away. I'm drawing a little away. Okay, so her little brother. Okay, then here is Sally's shadow on the ground, and here is her little brother's shadow on the ground. You see that two right triangles are drawn, right? And then you have to label the parts and with the proper numbers. I'm taking this one as ABC, and I see that Sally is 4 feet tall, so this is 4 feet, this is 4 feet. And next, her shadow is 3 feet long, so this is 3 feet. Her little brother's shadow is 2 feet long, and what is the height of her little brother? So, first of all, you have to set up a proportionality. Okay. By proportionality, if I am taking the vertical line of the large triangle, which is AB, over the vertical line of the small triangle, that is PQ, equals to the horizontal line of the large triangle over the horizontal line of the small triangle. At this point, you plug in the values. AB is 4, PQ I don't know, BC is 3 units, QR is 2 units. You know that we go for cross multiplication to figure out the value of x here. So it is 4 times 2 equals to 3 times x, then 4 2s are 8, 3x. You know how to eliminate x, how to eliminate 3 to isolate x. So division by 3, 8 over 3, 8 divided by 3, that gives you 2.667. So 2.66 or 2.6, that's fair enough. So this is the height of her little brother. This is the height of her little brother. Okay. Let me take one more question. This is slightly different. Let me copy this one. Okay. Let me go to my whiteboard. An observer who is 6 feet tall wants to find the height of the Eiffel Tower. He used a mirror so that two similar triangles are formed. So we know that these two triangles are similar. He made a plan as shown. Find the height of the tower. All of you can see that there are two right triangles. One is the small right triangle, and the other one is the large or the big right triangle, right? Therefore, these two right triangles are given similar, but the orientation is not the same. That means if I were you, really, I may get confused because I see that these two are really not having in the same position. So what I do is, just a minute. What I'm doing is this triangle. I want to change the orientation. Okay. Let's say that This triangle is drawn again separately. I'm drawing this triangle once again. Okay, let me draw carefully. A little weird. Please bear with me. Okay. Okay. So this triangle is representing this one. Now, if there is a mirror, how I got this new triangle? Is it by reflection or rotation? Is it by reflection or rotation? What do you think? How I got this one? Is it by reflection or rotation? Think for a while. It is reflection. Yes. So it is through reflection. Therefore, the horizontal line, I see that the horizontal line is here 4 feet. So here let me take 4 feet horizontal line, and the vertical line is 6 feet, and let me take 6 feet is the. Now I see that the orientation of the large triangle and the small triangle, these two are the same. So at this point, just let me assume that this is not there, just this is not there. Now, can you compare these two triangles? Means obviously, yes, you can compare these two triangles easily, and you can find the height of the Eiffel Tower. Okay, so let's see how to find the height of the Eiffel Tower. We have to set up a proportionality. If the names are not given, then you can take it as say A, B, C, and P, Q, R. You can take any letters for that matter. Oops, I'm sorry. P, Q, R. Okay, let me move this one a little down, otherwise it may be mixed up. Okay, now I know that these two triangles are similar, therefore the sides are proportional. So by proportionality, uh, the vertical line of the large triangle, which is PQ, over the vertical line of the small triangle equals to the horizontal line of the large triangle, which is QR, over the horizontal line of the small triangle. Now just plug in the values. I see that PQ is not given. AB is 6 feet, and QR is given 354 feet, over BC is 4 feet. At this point, we go for cross multiplication. And then compute. That is 4 times x equals to 6 times 354, and then go for inverse operation, do the calculations. Grab a calculator, and it's not difficult for you to do it at this point. 354 times 6, or 6 times 354, it's one and same, that is divided by 4. That gives you 531 feet. I don't know whether it is the actual height of the Eiffel Tower, it is 531 feet or not, but in this example, I got 531 feet. Okay, so now let me go to this one. The next question is exactly same as the question just now we discussed. And the following question is, find the height of the giraffe in the diagram below. A person is using a mirror, the same. And the next one is same. And here is a challenging question. A person, he is looking at the top of a statue's a statue, and there the horizontal distance is 10 feet, and he is looking at the feet of the statue, and he found that the vertical distance is given as 5 feet. What is the total height of this statue? That's the question. Now At this point, I want all of you to try